There you go. All right. I'm assuming everybody can see my screen. If not, then we'll just somebody will let me know. Cool. So thank you very much for being on this talk. I think well, not that we had other tracks, so this was kind of your only choice, but at least you decided to do this and not something else. I'm sure that if you're here, just like Tracy said, like the Raspberry Pi part is what caught your eye. Maybe not so much the Vault part, because we've heard Vault, it's a HashiCorp conference after all. But I think the interesting part is the unsealing with the fingerprint part of it, and it's kind of a fun thing to do and something that kind of brings everything together. By the way, as I was, I thought it was going to be a unique talk and that I was going to be the only one to talk about Raspberry Pis, but I thought I read that the very first talk this morning was about Raspberry Pis. I didn't get a chance to catch it, but I can't say I'm a pioneer. All right, let's get started. So a little bit of an intro, if you're not familiar with Raspberry Pis. I think many of you at least have heard of them, but just to kind of get a quick look at them, they're small single board computers, meaning it's like everything is like memory, CPU, and everything is on it. They're kind of like credit card size. Like I have one here. This is sort of like everything with a SD card for storage. They run ARM processors. I guess they're I don't know, a cheaper, more efficient, better suited for the small form factor. You can run a full operating system on them. You can run, Raspberry Pi has its own official operating system, but you can run Ubuntu. I've run Ubuntu, Debian, and other flavors, and they're affordable. I think that's the main attractiveness, is that on the lower end, there's a Raspberry Pi Zero. Literally costs $5, and you can still run, not a full operating system, but you can run an operating system with a desk environment for $5. Obviously, it has some limitations, and then the other side of the range is Raspberry Pi 4 with 8 GB of memory. I think that came out last summer for $75. And you can run, if that's the one that we're seeing on the screen there, you can run a full workstation with dual monitor, and it has like Wi-Fi, Bluetooth, 4 USB ports. So it has a lot just for $75, which is it's great. In general, it's used for like home labs or like things, you run your own clusters or things that you run at home. For Internet of Things, you want to connect your fridge to your coffee maker to your toaster or whatever. So like, and you can run things on it. DIY electronics, you see the little pins at the top. Those are just called GPIO pins. Stand for general purpose input output. You can control the signals on it and then connect to other components, or co-processing for microcontrollers. Microcontrollers being the other like more specialized hardware that's not a full computer architecture, but it can offload the heavy computing to a Raspberry Pi. Like I said, it has many different physical interfaces. As you can see here, the USBs, the Wi-Fi's, the Ethernets, all sorts of input-output components that can be plugged into the GPIO pins, as well as you see there the 3.5 millimeter jack has a connector for a camera, connector for a display. There's many other things, and there's an ecosystem around it. It's not just the board itself or the cases and whatnot. It has other computing things and input outputs like sensors and other devices that you can connect to it. Some of the concrete examples of things that you can run on Raspberry Pis is bare metal clusters, or kind of bare metal, I guess. Well, yes, you can consider bare metal. So Kubernetes and Nomad are examples. I run a Kubernetes cluster here at home. I'll show you in a second. You can run private VPN servers, because like this is pretty much a virtual machine. It's not a virtual machine, but you can interact with it and run the same things you run on a virtual machine. So you can be your own VPN provider for the cost of what a provider can charge you for like a month or two. Home automation, like I said, you can connect like sensors to things and lights and notifications and things like that. You can just connect a tiny Raspberry Pi to a large storage drive and be your own, or create your own storage NAS server. like micro weather stations, it's something that's a little bit more advanced, but it's kind of ideal because you have a bunch of inputs like rain gauge and temperature and things like that, and then have Raspberry Pi do the processing. So a few examples of things that I have at home. This is a Christmas ornament. This Christmas I put, you can see, but it's a Raspberry Pi Zero in the back with a mini display, and it was rotating a few pictures. That's my dog Monty on the left. You can really see it, but he's dressed as Superman. And then my friend's dog Benny, he's dressed as Batman. That was like 2 Halloweens ago. Scrolling messages, there's another Raspberry Pi Zero with a scrolling display, and I set up an internal endpoint that you can like go in and just change the message, and it's good for trolling when you're in the network. You can put anything there. Sound system, it's so that most of that wiring was already for like including the apartment. It's wired to some, I don't think you can see it there, but there's a speaker there, but it's only Bluetooth. So I'm running an AirPlay server on that Raspberry Pi Zero, so that I can also play from or better integrate like from my phone or laptop. This is kind of the center of the operations. This is my 5-node Kubernetes cluster in it, running on SSD drives with power over Ethernet right next to the router. There's a storage server there as well. I run all sorts of things here. I run Vault and Console for kind of internal purposes. I run other workloads. I run Prometheus, Grafana, and you'll see how those are actually kind of used in a minute. That is a little bit more kind of actual application. It's another Raspberry Pi Zero with a temperature sensor that I have inside my bedroom. So I capture the temperature and relative humidity in the room, and then those metrics get shipped to that Prometheus that is running Kubernetes cluster, and then I can display them in a Grafana dashboard. And the same, have an outdoor temperature sensor. This one's still kind of a work in progress because I think that enclosure is too weatherproof. So the readings are usually higher than they should be, but it's the same deal. They're connected to a Raspberry Pi Zero that's running inside the apartment and shipping the metrics. This was a fun one. I got a Bluetooth pulse oximeter. So I'm pairing it with a Raspberry Pi and then reading those metrics, and again, shipping them to Prometheus and then reading in Grafana. That's kind of, all of this is completely unnecessary. Like most of this is just for fun. It's like I didn't have to do any of this. I didn't have like a strict requirement. It's just, kind of got into the hobby, and it's a fun way to spend my time. So let me introduce myself and kind of before we move forward with the real content of the talk. I think it's an overstatement to say that I'm interested or have fun. I wouldn't say obsessed with, but I like to have fun with Raspberry Pis and IoT devices and all that. I'm Pato. By the way, I forgot to mention this. There's it's not a Raspberry Pi, but it's an IoT device. It's a programmable kind of screen, and it has like buttons here and whatnot. There's no interaction. I just put like a name badge. Literally, I got it yesterday, so I'm still gonna get started with this. But there it is. So, by the way, I don't use any of this in my day job. This is all completely personal. We're not in the hardware business. We're not in the IoT business. This everything I do by myself or for myself. My day job is a lead platform engineer at ASAP in New York City. Or at least as of last March, we were based in the World Trade Center. Haven't set foot there in a while. Really briefly, what we do a customer interaction platform. So imagine when you have to call or interact with your bank or your airline, we kind of create solutions in that space, and we put our own AI sauce. But AI, we make the emphasis that it's AI as in augmented intelligence, not artificial intelligence. We are trying to augment the human behind the interaction, not replace it with a bot. I used to be known as the unofficial HashiCorp ambassador because for any solution the solution to any problem that I would pitch would be either Vault, Console, Terraform, Packer, Nomad, Vagrant. So this is before Boundary and Waypoint. But so HashiCorp launched the official ambassador program last year, and I got selected, so I got to cross off that on from the unofficial. Lastly, I have a certification trifecta. Got Terraform Console and recently Vault. So I mean, it's kind of the associate level, but still kind of a proud achievement. Cool. So now the really kind of interesting part of the talk. So a little bit of background of how this kind of idea came about. So I don't know if you're familiar with the HashiCast. HashiCorp has an official podcast that is published, I guess, on I get it on Apple Podcasts, but I'm sure it's available a lot of other platforms. If you don't know about it, you should check it out and catch up on it. There's 26 or 27 episodes, I think. Really cool guests. You know, all sorts of topics are covered and a lot to learn. So I was listening to episode 23 from October, I believe. And Rosemary, who was listening to this, and I know she is very interested in this, she was interviewing somebody from the Vault team, and she asked the question, will there ever be a fingerprint scanner to unlock Vault? So my thought immediately was challenge accepted. So at this point, I was already familiar with sort of the like what we can do in the Raspberry Pi world and the inputs and or the sensors and all that. So it's like, you know, it shouldn't be too hard to do. It may not be like the previous solution, but I'm sure I can get something done. So you may ask yourself why, and the answer is simply why not? Like I said, all of this was mostly for fun. I wanted to have, usually as engineers, when we were busy, or sorry, when we're not busy, we invent problems so we can invent solutions to those problems. So this is like an interesting problem to try to invent the solution to. So yeah, why not? I do have to give you a warning though, and it's important that you understand this. Like I said, this is for fun, so do not do this in production or in any environment that you cannot afford to lose. This is experimental. This is a one-off. Most importantly, do not rely on this. This is, even if you get to make it even if you get it to work, you should not rely on this because this is kind of untested. I've only done it on like my own personal environment, so do not rely on this. This is also not an official HashiCorp tool. It's a set of like scripts and integrations that I wrote. It's not even part of the. It's not even a branch on the Vault code. So non-official HashiCorp tool, as well as there's no support for this. I'll show you the code. I'll share the code and demo with you, but then there's going to be no further updates after this presentation. So hopefully that is clear. Is that clear? If it's not clear, let me reiterate. Do not do this in production. Any environment you cannot afford to lose. Do not rely on this. Not official. No support. No further updates. Got it? Cool. So demo time. Before I get into the demo, I want to say that kind of ironically, I think that demo with hardware is less reliable than or less predictable than demos with software. So I decided to pre-record this. And actually it was a good idea because there were a few glitches and I had to re-record many times. So I'm going to show you a video. The video has no sound. I'm going to be narrating over it so that you get a picture of what's going on. And there's going to be a bonus demo after the fingerprint one. So stay for that. Wait, there's not this. Cool. All right. So before I press play, let me just kind of briefly explain what's going on there. There's a Raspberry Pi there. It's actually an older Raspberry Pi. It's a Raspberry Pi 3B. I think it has like just half a gig of memory. So you can see that you can run this in a smaller hardware. There's the fingerprint scanner there connected via USB to the Raspberry Pi. The screen you see on your upper right corner is the screen you see within the screen is the same as the larger screen. So I just want you to get a view of the commands and what I'm typing, but as well as the physical interaction. And then you have an 8-bit amiibo link on the left there that he has nothing to do there. He's just there for decoration. Cool. So this is I'm shelled into Raspberry Pi, onto that physical Raspberry Pi. I'm running Vault locally as a systemd unit. So all those commands are going to be running against a Vault running there. And let's press play. So okay, so we started with the Vault status just to show that Vault is uninitialized and obviously sealed. So we're going to run this script. Vault VFP is Vault fingerprint, and we're going to enroll the finger that we want to interact with. So press my finger there, remove it, and then have to place it again to confirm identity. Cool. So that means that finger is going to be recognized, and I'm going to be able to use it. So now we do the initialization ceremony we have to do with all Vault clusters. So place the finger that was enrolled, and there you go. Let me make a quick pause there. So it prints out the root token, and it also generates 2 files. This is kind of part of the reason why this is not really secure. You shouldn't do this in production, because there's the fingerprint sensor doesn't really provide encryption or even protection to access to the data. So the real encryption, the real protection is on external files. So what the script does is it generates a key and then puts it in one file, and then encrypts the unsealed keys, puts them in another file. So that way, at least you can sort of separate or distribute the files, and access to one doesn't mean access to the other, but still you have a less secure kind of system there. But like I said, it's for fun, and let's keep moving forward. Okay, so that took care of the initialization. I'm going to copy the root token so I can interact with Vault later. Not going to use it yet, but for now I'm going to just check for Vault status to see that it is initialized, but it's still sealed. So now we have to go through the unseal process. So we call the same script, but now the unseal command, waiting for the finger, and press there, and got recognized and got unsealed. It is at this moment that I have to say to Rosemary, challenge achieved. But there's a little more, so let's keep moving forward. So Vault status again, now it shows that it's initialized and it's also unsealed. So because we have the root token, the environment variable, we can try to interact with it. So let's enable a secrets backend, the KV backend. It's enabled there. Sort of put a secret foo with some content in that path, and successfully written. So now try to read from it to make sure that it's there. There you go. Now, this is a key part. It's restart Vault to force it to be resealed. We know that when a process restarts, you need to unseal it again. You see that it's sealed there. So we run the same process, vfp.py unseal. So what happens now is, what if I try to unseal it with a finger that it was not enrolled? So I try, tap, doesn't work. Okay, so now let's try with the index finger. It failed once, but it unsealed. So this is what I was saying, it's not really that reliable. So I check Vault status, see that it's unsealed again. Try to read the same secret that I had before, and it's there. So that's it. That's mostly it for the demo for this, but I promise there's going to be a bonus. So I mentioned before that there's an ecosystem of inputs and kind of gadgets and thingies that you can do with Raspberry Pi. So I decided to do a similar exercise, but using RFID cards or fobs, or like the things that you use for your apartment complex or your office or whatnot. So I'm going to do a similar exercise. I wrote a similar integration using those keys and storing unsealed keys onto the cards, so that you have a similar interaction. So that is this video. And yeah, so setup is sort of similar, same Raspberry Pi, it's just that it has the RFID reader there plugged into the GPIO pins. link is still there. And fun fact, Nintendo Amiibos are RFID cards. You just can't write to them because they're locked, but you can read from them. So essentially, I could have unlocked Vault with an Amiibo as well. Or I could have hacked it, I guess. So let's press play on it. Same deal as before. Try to check the status of Vault. Vault is uninitialized and obviously sealed. So it's a different script. It's on the same repo that I'm going to show later. Now I'm going to pass the number of key shares. It's equivalent to the number of Unseal keys, but it's how many tags I want to use. So scan the first one, scan the second one, and here we go. Scan the third one. I don't know why the last two have the same ID. I just realized after I was recording the video, but there you go. So Vault is initialized at this point. Check the status, and it's certainly initialized. Got the root token there. Oh, I should pause for a second too. So the other reason why this method is also not secure is because the Unseal keys are stored unencrypted on the keys, and unless you lock the key or the RFID card itself, then it's easy to copy, and it's sort of like it's less secure. You still have you have the benefit that you have like 5 physical different things you can distribute geographically and put at different keychains or like actual vaults or whatnot, but it's still sort of not. Probably this can be done into something more secure, but I didn't do it that way for this demo. Cool. So Vault is initialized, still sealed. We get the root token. We put it there. So now we are going to unseal it. We're going to use the tags that we were using before. So press that one there, detected. Press the second or scan the second one, same ID, but we know it's a different one. And third one, Vault is unsealed. We can run the same exercise or the same checks as before. Vault is initialized, Vault is unsealed. We have the root token, it's an environment variable, so we can run the same exercise as before. We're enabling by the way, this is before I started this demo, I restarted and it was a brand new Vault instance. So this wasn't there before. So I created the KV backend, injecting a secret. It's written there. Get the secret, it's there. Now we're gonna do the same kind of verification. I can force a restart of Vault to make sure that it comes up and it will be sealed. So check the status, initialized but sealed. Then do the same unseal process, scan the tags. 1, 2, takes a minute, there you go. And 3, so Vault is unsealed. We can once again run the run commands, and there you go. It was read. Okay, so that was the end of the demos. Back to the presentation. Actually, there's not a lot more in the presentation. There's a few links here. You don't worry about writing them now. I'm going to upload the presentation here. I do want to point out there's the link to HashiCast, or just look for it on your podcast app. Make sure you listen to episode 23, but also catch up on all the rest. There's the demo code there with the scripts and a little bit of instructions. Try to get the Raspberry Pi set up for this demo if you want to give it a try. So a few links to the parts that I used. Big shout out to Adafruit.com. It's a local shop they're based in New York City. Is where I buy most of my Raspberry Pi related stuff. They have really cool. It's not just the hardware, but it's also guides, and they do videos and do a lot of content on Twitter and YouTube. So it's quite cool. Give them a follow. And that's pretty much it. I think we have a few minutes. I don't know if there are any questions. If there are, I'm I'm happy to. Okay, Tracy has a question. So yeah.
Since you were the perfect end to my emceeing duties, and so before I hand you over and also release you to the YouTube chat,
Yeah.
if you don't already know, what would be the best way to troubleshoot why the UIDs for two of those readings were the same, but the unseal key was different?
I don't think the UIDs for the tags are guaranteed to be different. They just happen to be two batches from the same vendor that I bought on Amazon. They just have like sequential UIDs. So you could see that they were actually different because there's no way there could have been two keys to Unseal Vault when it required three. You know what I mean? Yeah, I have a bag of them that I bought. I try to get just 3 for the demo. I could only buy minimum 20, so I bought 20. I guess it's just unlucky to actually. There's one free one that came with the scanner plus a bag of 20. So probably those two. I just happened to grab the free one and then the other one that came in the bag that were had the same UID.
Awesome.
Actually, that's a good question because this is the kind of thing that. Like my background is in software development, but also like now lately, obviously in the last few years, I've been more in like infra and digital infrastructure and all that. Hardware is a mystery to me, so it's not a mystery. I understand it. It's hard to actually get a good grasp on. And that's the other cool thing about Adafruit. They publish libraries for the hardware that they sell. So it's kind of like they writing the API so that I don't need to know about like packets and like bits and bytes and like random things that I don't want to know about. Just give me the API. I write against that API, and that's it. And that's what they're amazing.